Dear students, we are discussing refraction of light, and in our previous video we have covered the application of refraction. Now this is very important part of refraction of light by spherical lenses. Okay, we have spherical lenses, and these lenses also shows the refraction, and these are very important things for us, okay, which works on the phenomena of refraction. Okay, now there are two type of lenses, number one convex and number two concave. Okay, we already discussed about mirror also, spherical mirrors. Now we are talking about spherical lenses. Okay, so there are two type of spherical lenses, number one convex lens and number two concave lens. The simple difference between convex and concave lens, you can see a convex lens is thick at the center. Okay, this is thick at the center, at thin at the edges, and in concave lens you can see a concave lens is thin in the middle but thicker at the edges. So this is concave lens and this is convex lens. This is very important thing. By touching the concave and convex lens, we can get, or we can know about the concave and convex lens by the thickness of their material. Okay, now let's discuss about the optical center and the principal axis of a lens. Okay, it's very simple. The center point of lens. Okay, in this lens you can see this would be the center point, and in this lens this would be the center point. Okay, here only. So the center point of the lens is known as optical center. Okay, in mirrors we discuss about pole, but in lenses we talk about optical center, number one. Second thing, the about the principal axis. Okay, what is principal axis? The principal axis of a lens is a line passing through the optical center. The line which passes through the optical center, that line is known as principal axis. Okay, and it's very important that it is perpendicular to this surface. It is perpendicular to this surface. Okay, this is important point. Now we discuss about the principal focus of convex and concave lens. Focus is also very important. There are two type of focus in convex and concave lens. We discuss about the principal focus. Okay, in convex lens, this lens is also called a converging lens. I think you know about the meaning of converge. Okay, converge means the light rays coming closer when passes from this lens. Okay, in this case you can see here, suppose this is a light ray, this is a light ray. Okay, you can see diagram here also. So after passing through this lens, it converge like that, deviates. Okay, lenses reflect light like. So this point is called focus. This is very important thing. You can see here in this diagram, this is a lens, this is a optical center. Okay, midpoint of a lens is called optical center, and the line which move through optical center is known as principal axis. This line is principal axis. Okay, now about focus, the principal focus. For to find the principal focus, we have to do one thing. We will incident a light ray parallel to the principal axis. Okay, when we incident a light ray parallel to the principal axis, after a refraction through a lens. Okay, after a refraction through a lens, it cuts one point of a principal axis. That point is called a principal focus of convex lens. You should know what is the principal focus of convex lens. The principal focus of a convex lens is a point on its principal axis to which light rays parallel to the principal axis converge up after passing through the lens. This important point. Okay, there are two focus. Okay, this is main focus, or you can say this is the principal focus, and the another focus is also there, that is exactly the same distance from the optical center. Suppose the distance of optical center and principal focus is 2 centimeter, then on at the left side, at the distance from the optical center to focus take 2 centimeter, that point is also called focus. So there are two focus in convex lens, in concave lens also, but you should know about the principal focus. Okay, this is important point. So one important thing, this principal focus, you can see here, this is a principal focus, and in reality, okay, these light rays are meeting at a point. So this focus is a real focus, not virtual focus. We know about real and virtual things. Okay, now let's discuss about concave lens. Okay, this is a concave lens. As I already told, by the thickness we can compare the lenses. Okay, this is thinner at the middle, in the middle, and this is thicker at the edges. Okay, now and what is the optical center of this? The midpoint of lens is optical center, and the line which passes through that optical center is called principal axis. Okay, these are the points. Now what about the focus of this concave lens, principal focus? Because it also shows two focus, but we will discuss about the principal focus. For that, to find the principal focus, we will do the same thing. Okay, we will draw a light ray parallel to the principal axis. Okay, we are drawing light rays parallel to the principal axis. Okay, after refraction, you can see after refraction the light ray is moving like this, because this lens is also called diverging lens. Okay, this is a diverging lens. It diverges the light rays or spreads out light rays. Okay, so in this case, how to find the focus? Same thing. Okay, these light rays are moving far from each other, or we can say far from principal axis. Then we will do one thing, we will draw the line. Okay, we will draw the line backward, and at that point where these lines cut the principal axis, that point is called focus. So you can see here in this diagram, this is a focus, and this focus is virtual, because this is not real. Okay, not real intersecting of light ray, so such focus is called virtual focus. So in this case, to find out the images, okay, we there are different cases to find out the images. Okay, there are 6 cases in convex lens and 2 cases in convex, and 6 cases in convex lens and 2 cases in concave lens. So there are some important rules for obtaining images formed by convex lens. Okay, at first discuss these rules are same as like mirrors. In case of convex mirror, you can say, you can see here, this is first rule. When we draw the light ray parallel to the principal axis, it moves from focus. Simple law. This law is also this law was also in mirror. Okay, when we draw light ray parallel to the principal axis, after refraction it moves from focus. Okay, now in second case, when we draw a light ray from optical center, then it goes straight. Okay, then it goes straight. And this is a third rule. When we draw a light ray, okay, from focus, then after refraction it becomes parallel to the principal axis. So these are important rules, you have to memorize them. First rule you can see, when a ray of light parallel to the principal axis, after refraction it moves from focus. Number 2, when a light ray moves from optical center, then it goes straight. And number 3, when a light ray moves from focus, then after refraction it becomes parallel to the principal axis. So these are the rules to find out the image for convex lens. Okay, then we have different cases, different types for formation of images by a convex lens. Okay, like concave mirror, there is just opposite. Okay, concave mirror, there were 6 cases. Okay, in concave mirror. So same thing here in convex lens, there are 6 cases. And in convex mirror, there were only 2 cases. Here also in concave lens, there are only here only 2 cases. Got it? So in these 6 cases, we draw all kind of images. At first, when object will be at the between focus and optical center, then after that when the object is at focus, then after that when object is between f and 2f, then beyond 2f, like that. Okay, we will do one thing here. This is suppose this is your lens. Okay, we know this middle point is optical center and this is a principal axis, and in this is focus. Here in mirror we write 2, that is center of curvature, but we do not write here center of curvature. It is just the twice of the focal length. Okay, then we write this point as 2f. So at first we do when an object is between O and F, means optical center, between optical center and focus. Then in second case we do then when an object is at focus. Then after that when an object is between f and 2f. Then in another case when object is at 2f. Okay, then at after that beyond 2f, then after that infinity. So these are the cases, just like mirror. Okay, today go through this video. Thank you.